Hi everyone, happy Friday. So today we will start session 5.3 and today we will also go over the quiz 3. Okay? When is the exam?
Next Friday.
Next Wednesday. Next Wednesday. So the practice exam is due on Tuesday. Okay everybody, have you started the practice exam?
It said on Blackboard that it was due yesterday.
It's okay. Because our old exam was today. That's why it was set like yesterday. But it's okay. You can turn in late. You can still submit the work.
Okay,
I
all right.
won't count it late. Yeah. Okay. Uh, so the exam is on Wednesday. Okay. So try to come here early. Okay. So when you finish your previous class, come here as soon as possible. And then I have class right after our class in the same room. So if you need more time, you can stay. Okay. But you can expect I will be teaching the class when you stay. Okay. So when you finish the exam, you just put it on my desk and then you can leave. Okay. So yeah, something wrong with this projector. Let me just turn it off. Okay. All right. So let's talk about the quiz 3. Okay. So yeah, if you have any questions about your homework or practice exams or class notes or quiz, please feel free to come to ask me. Yes?
I realized that we couldn't see our feedback on the quiz, but I could see it.
Oh yes, that's right. I think something wrong with the quiz. That's why I give you the quiz mistakes. The quiz mistakes, you can see your mistakes. So you can see everybody's mistake. So like here, we will go over the quiz mistakes. So you can see what you got wrong and then how many points I take off. Okay? Yes. Yeah, it's the setup of the Blackboard. I'm not able to give you feedback in the quiz session. That's why I make this quiz mistake so everybody can learn from the mistake. Okay, so the first problem was pilot rule. Right, first guy prime times second guy plus first guy times second guy prime. And then you take the derivative, and you get this right, which is good. So then the part B is chain rule. ln of u derivative is 1 over u times u prime. Some of you forgot the u prime. Okay, so don't forget that. And the u prime, 3 times x to the 1 half, derivative is 1 half, x to the minus 1 half, and then 5 times 6, x to the 5th. So you can put them on the numerator. Okay, you don't have to simplify it. You can leave it like that. And then part C, this is quotient rule, right? First guy prime times second guy minus first guy times second guy prime over the denominator square, right? So make sure the parentheses, your baby, put them on the correct spots. Okay. So yeah, we have 3 questions on the quiz. Let's look at the mistake together. Okay, so here the mistake is this is x to the 1 half, not 3 to the 1 half x. 3 times x to the 1 half. That's why the derivative is 3 times 1 half x to the minus 1 half. Okay? And then here, everybody say baby. Baby. Who's your baby? Parentheses. Okay, everybody? Don't forget your parentheses. And your denominator is still here, so don't forget your denominator. Okay? So for the factor has no prime, just copy down. Okay. And then, right, so this, here, there should be a prime here. Okay, so before you take the derivative, you need to include the prime. So after you take the derivative, you don't write the prime. Okay? And here, chain rule, 1 over u times u prime. Everybody say u prime. U prime. Everybody? Did I hear you? U prime. Chain rule. We always multiply u prime at the end by itself. Okay, everybody? Okay. So, and then here, the derivative of ln x is 1 over x. The derivative of 7x is 7. So get rid of the x. And then the handwriting, make sure your 5 looks like a 5, do not look like a 3. Okay? All right. So yes, we learned from our mistake. I hope the quiz can help you better prepare for the exam. Okay, and then here, the derivative of e to the 3x is 3 e to the 3x. Yeah, that's it. Don't multiply by the 3. Okay? We already multiplied the 3 before the e to the 3x. And that's good. That's good. Okay? So don't need to multiply another 3. Okay, 1 over u times u prime. Put the prime there. And then here you remember to differentiate. Yes, but be careful, put the prime there. So they are equal. Every step they are equal. If you don't put the prime, then this is just a function. Is the function equal to the derivative? No, only if the function is e to the x or the constant 0 function. Okay? They are the only two functions. The derivative is itself. So with the prime or not, they mean different things. Okay? So hello, we're talking about the quiz. Okay? So so you know how to see the quiz mistakes on the website. So we were talking about like here the handwriting. So make sure you can see the difference between 5 and 3. Yes. Otherwise, this one looks like a 3. Okay. And then this problem, make sure you put the u prime, the prime, the derivative and the function, they mean different things. Okay? Oh, and then here the formula of ln u, derivative of ln u is 1 over u times u prime. Okay? So be familiar with the formula. Do you remember I asked you to a paper and then write down those formulas? So make sure you memorize those formulas. Okay. And then here, parentheses. Everybody say parentheses. Parentheses, your baby. Okay? So you have the parentheses should be next to the e to the 3x. Okay? And then that side, the parentheses should be after the 7x. Okay. So baby is very important. If the parentheses, we put them into different spots, it means different things. Because if the parentheses is here, it means only e to the 3x is multiplied by the second factor. The first term, the 4x to the 5th, is not multiplying by the second factor. Okay, everybody? So be careful. Oh, that's it. Any questions about quiz 3? Again, when is the exam? Next Wednesday. So try to come here early. And if you need more time, you feel free to stay longer. But you expect I will be teaching my next class here. So it will be loudy here. Yes. Okay. So let's continue. 5.1. Okay. So we were talking about the derivative is the slope of the tangent line, right? And then we also have the critical points, and we have the first derivative test. Okay, look at me. If the derivative is positive, then the function is increasing, right? If the derivative is negative, the function is decreasing. If the function increase and decrease, this is a local maximum. If the function and the derivative is negative, the function is decreasing. And then the derivative is positive, the function is increasing. What's this? Local mean. Okay, everybody? So to find the local extrema, the step is, okay, so we did some example last time, right? The step was we find the derivative, and if you don't see denominator, your goal is to factor. Everybody say factor. Factor. Yes. We set it equal to 0. And then this is the same as saying we set each factor equal to 0. We solve for x. And then we find the domain, right? Everybody, critical point, 3 things. 1 is in the domain, right? 2 is either the derivative is 0, or 3, the derivative does not exist. Okay, everybody? So if you don't see a denominator, well then you just factor it and set it equal to 0. Then you draw the real number line separated by the critical point, and that divides the real number line into some sub-intervals. Right, everybody? Okay. And then you construct a table. So you talk about the derivative and the function. The derivative, you want to talk about whether it's positive or negative or 0 at the point or does not exist at the critical point, right? Okay. And then function, you're talking about increasing or decreasing. Okay. And on each sub-interval, you take a test point. Okay, everybody? And then you plug in the original form or the factor form. Factor form. See, if you plug in the original form, you might need to use calculator. Right, everybody? But if you plug in the factor form, for each factor, you can see right away whether it's positive or negative. And then you see, okay, how many negative multiplied together? If it's an even number of negative, then your result is positive. If you have an odd number of negative multiplied together, your result is negative. Exactly. See, you don't need a calculator at all. Okay, and then the third step, you answer the question, the conclusion. Okay, f is increasing on which interval, decreasing on which interval, when does it have local max or mean. And then we also did example 5. When you take the derivative, do you see some negative exponents? Negative exponents means that thing should be in the denominator, right? So we have a denominator. Okay, then the process is longer because you have 2 terms. One of it has a denominator. Then you need to combine them to a single fraction. Okay? If you get a single fraction, the numerator equal to 0 corresponds to the derivative is 0. The denominator equal to 0 corresponds to the derivative does not exist. Right, everybody? So you need to look at both of them. You find the critical point and you need to see the domain. Because sometimes maybe a domain does not include one of the critical points. Okay, everybody? In this case, when you draw the real number line, let's say if, okay, in this problem, the domains are real number. Let's say if we have another problem, the domain is x not equal to 0. But then when you draw the real number line, you actually take out the 0. Okay? So then you have the other critical point, 4/5 here. Okay? So the picture is similar, but you know here, this is the domain, x not equal to 0. So therefore, this point is missing. The derivative does not exist. Your function is undefined. Okay? So undefined, then you don't have a local max or local mean. The point is missing. Usually, this picture will be like maybe like this. So that's why here you have a like vertical asymptote, so you don't have a local mass or local mean here. Okay, so sometimes it's like this. Okay. And last time we did some application problems. Do you remember this problem? I think your homework has some problem like this too. So we were talking about the profit is revenue minus cost. You get the function and you want to find the maximum profit. Maximum profit. Okay. Remember, we get the critical point was 14, right? And the domain is greater or equal to 0. So we can draw the table and we can see that is the local max. It's in fact an absolute maximum, right, everybody? Because from the picture, when we're the one point is 0, on the other side it goes down forever. So we get absolute maximum profit when x is 14. Then the maximum profit is so you plug the 14 into the profit function, which is here. So negative 3 times 14 squared plus 84 times x. X is 14 and then minus 1. Okay, what do you get? Wait, do you have a calculator?
Yeah.
Mm-hmm. Yeah, everybody try it too. So put this in your calculator. Let's see if you get the same answer. Like this? It's a bit different. What do you get? Yeah, 587. Maybe you missed a minus sign somewhere. That's why use your calculator. It's better because you can type everything in one line. Yes. Okay, so that is the maximum profit. We find the maximum profit. So check the questions. Did you answer all the questions? And also we want to find the price to charge per leash to maximize the profits. Okay, price. Price is the revenue over X. Does it make sense? Revenue is the money you earn. Okay, and then you divide it by X items. You get the price, right? Because your revenue is the price of each item times the number of items, right? So revenue is what? Negative 3x squared plus 90x. And when we divide it by x, do you see all the x power drop down by 1? So we get negative 3x plus 90. Is that okay, everybody? And the price. Okay, the price when x equals 14, our price is negative 3 times x is 14 plus 90. Okay, what is this? Well, put this in your calculator. What do you get? Okay, revenue is the money you earn. Okay, the amount you earn. What is this? That is the sale price. So each item you earn that much sale price times the number of items. Right?
So the X is the number of items.
Yeah, X is the number of items. Right. Okay. So, oh, Will, what do you get?
I got 48.
48. Thank you. So we get 48. Okay, so the price is 48 to maximize the profits. Okay, this is the example. I think 48 is too expensive for the job. Do you agree? Maybe $3, $5 I would buy it. 48 too. So yeah, this problems are just examples to try to make the numbers nice. Okay. Yes. The real life problem, you might not get a nice linear function or other function. It would be like harder function. Okay. But this is the idea. Okay. Any questions about example 7? All good? Okay. So you have revenue, cost, profit. Yes. Okay. All right. Have you taken some like business course, economics course before? Yeah, like your high school, do you have like economic course? Oh, okay. Some of you have, some of you don't. Okay. So. All right. Example 8. The metabolic rate after a person eats a meal tends to go up, and then, after some time has passed, return to a resting metabolic rate. The phenomena is known as the thermic effects of food and can be described for a particular individual as the following. So we have the function. Oh, you see this function? We have t and exponential function. Okay, and t is between 0.1 and 3. When f of t is the thermic effort of food in kJ per hour, okay, and t is the number of hours that has elapsed since eating a meal. Part A. Find the intervals of the time during which the thermic effect is increasing or decreasing. Okay? So we want to find the interval such that the function is increasing or decreasing. Find the time after the meal when the thermic effects of the food is maximized. Okay, so we have this function. We want to find the interval of increasing and decreasing. We want to find the maximum. So let's do the first step. We want to take the derivative. Okay, let's take the derivative. Do you see the first number is a constant? Derivative of a constant is 0. And then the second term, do you see this is a product? We have the t there, so we need to use product rule, which is the first factor, 175.9 t prime times the second factor plus the first factor times the second factor prime. So this is product rule. So far, so good, everybody? Dylan, what is the derivative of the first factor? Yes, the t just disappeared. Okay, the derivative of linear term become a constant, the coefficient in front of it. Okay, and then we copy down. Page, what is the derivative of e to the negative 1.3t? Negative 1.3 times e to the negative 1.3 t. Right, everybody? So don't put the t here. No t here. Just the number, the coefficient. Okay? E to the kx prime is k times e to the kx. Do not put the x here. Okay? Alright, so be familiar with all the derivative formula. Okay, so let's see. Our goal is to factor. right, everybody? Our goal is to factor. What's the common factor? Do you see both terms has the factor 175.9? And it also has e to the negative 1.3t, right? Okay, down J, what's left? What's inside the parentheses? Hmm? Do you have t? The first term. One, yes. How about the second term? 1 plus 1. T? Okay, so t, right? And so if it's 1, then you don't need to write it down, right? Because 1 times anything is just that thing. Mm-hmm. What number is left? Yeah, negative 1.3, right, everybody? So this is the same as, say, this is like 1 minus 1.3t. Yeah. So this is the same as this. Okay? Yes? Oh, break down what? Oh, you want to take out the common factor. So look at this. Look at the second term. You take out this common factor, what is left? It's like if you have a plus ab, your common factor is a. You take out a, what's left? Oh, this is like 1, right? Yeah. And what's left is the b left. And then here, oh. So a is that 1.175.9 and e term. That's like the a. When you take out that factor, you get 1 left. And then the second term, you take out that factor. What's left is t and negative 1. Oh, okay. Yeah. Okay, so that is, you can switch the order of t in the negative 1.3. So you get 1 minus 1.3 t. Okay, so okay, maybe let me just write this down, make it look nicer. Okay, we set this equal to 0. Do you see 175.9? This thing is always greater than 0. And do you see the exponential function is always greater than 0? Right? Exponential function, e to the x looks like this. And e to the negative x looks like that. Right, everybody? So, but it's always greater than 0. So the only possibility this thing equal to 0 is when 1 minus 1.3t equal to 0. How do you solve for t? Questions? Oh, 1 minus 1.3t? Oh, it's t times negative 1.3. So you can, because multiplication is commutative. That's why it's 1 minus 1.3.
So you're doing inside parentheses?
Yes, right. It's inside the parentheses. It's like t times negative 2 is negative 2t. Then you can get rid of 1. Yes, good. All right. Mackenzie, how do you solve for t? Hmm? Sorry? Yes, put it in steps. Mm-hmm. Yes, good. Then t equals what? Mm-hmm. Which is approximately equals to your calculator? Oh, how about 3 decimal places? Thank you. Okay, so this is the critical point. Okay, everybody? And then you talk about the domain. Do you see our oops. Okay. Here, our domain for this problem, our t is between 0.1 and 3. Right, everybody? That is our domain. So good. Now we can draw the domain is from 0.1 to 3. And my critical point is here, 0.769. Okay. And this interval is 0.1 and 0.769. And this interval is 0.769 to 3. Is that okay, everybody? So you draw the table. So you are care about the function f prime and the function f. At that critical point, f prime is what? Gabby, at that critical point, 0.769, what's the derivative? Yeah, it's just 0, right? That's how we get that critical point. We set the derivative equal to 0. Okay, so before on the left interval, let's pick some test points. What point do you take? Left part. What? 0.5, yes. So 0.5, we plug in the factor form, right, everybody? The factor form. Oh, do you see the 175.9 is always positive? And then the exponential function is always positive? So you put 0.5 into the last factor. 1 minus 1.3 times 0.5. Is it positive or negative? Let's think about it. 0.5 is like half, right? Half of 1.3 is 0.65, right? 1 minus 0.65 is 0.35 positive, right? So all we know, the derivative is positive. You don't need to get an exact number. You just need to know whether it's positive or negative. How about the second interval? What number do you pick? 1. If you plug in 1, what happens? The derivative is positive or negative? Negative. Very good. Okay. If your derivative is positive, then your function is increasing. If your derivative is negative, then your function is decreasing. Oh, what is this? Max. Right, everybody? Yeah, it's the maximum. It's not only local maximum, it's also global maximum. Okay, yes. So therefore, part A, we see F is increasing on the interval 0.1 to 0.769 and is decreasing on 0.769 to 3. Okay, everybody? And part B, we want to find the time when the F is maximized. So F has maximum, it's actually an absolute maximum, okay, from this picture, okay, at t equals to 0.769. And then we finish the problem. So far, so good, everybody? Look, we have a story problem. No matter how complicated the story here, You only care about the function. Okay? That as long as you know the function, then the process is the same. You take the derivative, find the critical point, find the domain, and then draw the table. Everybody? Yes. So we finished 5.2. Okay, let's look at 5.3. Okay. Okay, 5.3, higher derivatives, concavity, and the second derivative test. So big idea. Concavity refers whether the function, the graph of function looks like a ball. So it looks like a ball. A ball is like this, okay? So that's concave up, okay? Or looks like an umbrella. Umbrella is like go down, okay? Open down. So this is concave down, okay? Think about it. A bow, it always face up, right? Umbrella, okay, is it face down because the ring comes on top of it. Yeah. The second derivative of a function is positive on the interval where the function is concave up. So the second derivative tells us whether the function's shape is concave up or concave down. Okay? The first derivative tells us whether the function is increasing or decreasing. The second derivative tells us whether the function is concave up or concave down. Big skills. You should be able to use the second derivative of a function to find intervals of different concavity, and also use the sign of the second derivatives to tell whether a critical point is an extreme. Okay, let's look at concavity and inflection points. Okay, so let f be differentiable on an open interval. If the derivative, okay, this is not a typo. This is not a typo. This is if the derivative is increasing, then the function is concave up. Okay, let's draw the picture. Okay, let's look at this. Do you see here the slope is negative? And here the slope is 0, right? Here the slope is positive. And you know the slope is the derivative. You see a derivative is from negative to 0 to positive, so the derivative is increasing. Do you agree, everybody? So if your derivative is increasing, then the function is concave up. Okay, look at this picture. The derivative is the slope is increasing. Okay, do you remember that a function is increasing? Then that means the derivative of the function. See? You can take the derivative of the derivative, then you get the second derivative. If the function is increasing, then the derivative is positive. Does that make sense, everybody? Yeah, you take the derivative of the derivative, right? Because the first derivative, the slope, is increasing. Therefore, the derivative of the slope is positive. Does that make sense? That's why the second derivative is positive. Then you have your function looks like a ball. It's concave up. Okay. And then next, if the derivative is decreasing, let's draw a picture here. Decreasing. Okay. See? Here, slope is positive. Here, slope is 0. Here, slope is negative. Do you see positive, 0, and negative? Your slope, excuse me, is decreasing. Decreasing. Okay, that's why if your function is decreasing, then the derivative of the function, which is the second derivative of f, is negative. Okay, so the second derivative tells us whether the function is trending up or trending down. If the function is continuous at c and f change concavity at c from up to down or from down to up, then we say f has an inflection point at c. Okay? If you draw the picture, the inflection point is really like the turning point. Okay? Think about it. If you are driving, so this is like your car. You're driving. Okay, if you're driving this direction, well, it looks like you turn right. Do you agree? From here, see, you turn right, you turn right. Oh, but at this point, see here, you turn right, but then after this point, you turn left. Do you see, everybody? So the inflection point here is really like the turning point. Can you see here? You still turn left. Yep. Can you imagine, everybody? You still turn left, but after this point, you turn right. Okay? So the inflection point is really like you turn left, but you change to turn right. So that's why if you're driving a car, the inflection point is like the turning point where you change your direction, turn left or turn right. Okay, everybody? All right. So inflection point. Here, we talk about critical points and inflection points. So critical points. Let me write this down. Okay. So critical point. C is a critical point if first C is in the domain, right, everybody? And then either the derivative at C is 0 or the derivative at C does not exist. So critical point is about the first derivative. Okay, everybody? Then the inflection point is about the second derivative. So C is an inflection point if, first, it must be in the domain. Okay? Second, we have either the second derivative is 0 or the second derivative, any guess? Is 0 or does not exist. One more condition. We require the second derivative change sign. Is that okay, everybody? So comparing with critical points. Okay, the critical point, it could be a local max or it could be a local min. It could be neither. We don't require the derivative change sign. Right, everybody? But the inflection points, it requires the second derivative change sign. Because think about it. This is the turning point, right? You must turn your direction from left to right or from right to left. Otherwise, it's not called a turning point. Do you agree? Yes. Very good. So that's why for the critical points, we have 3 conditions. But for the inflection points, we have 4 conditions. Okay, everybody? Now, 2 and 3 is either one. We just need one of them to satisfy. Okay, task for concavity. Suppose the second derivative exists on an interval. If the second derivative is positive, then the function is concave up. Yeah, we already showed that, right? Concave up. The second derivative is positive because your slope is increasing, right? And if the second derivative is negative, then the function is concave down, right? Because your slope is decreasing. Yeah? So the second derivative is negative. Yeah, so C is a point of the interval at which the second derivative is 0 and the second derivative change signs, and F has an inflection point at C. So actually, we also allow the second derivative does not exist. Okay, that is allowed. Okay. All right. So let's look at this picture. So from A to B, do you see we have looks like an umbrella, so it concave down, right? And then from B to C, do you see it's like a ball, so concave up? C to D, and looks like a part of the umbrella, right? So still concave down. D to E, concave up, and E to P is still concave up. You see, everybody? And P to Q is concave down. Yeah. So we mark C as a point at which the second derivative is 0 and the second derivative change signs, and F has an inflection point at C. However, the inflection point may occur at a point where the second derivative does not exist, like the point E in the above picture. Picture. The point E, if on the left side of E, the function concave up, okay? But the right side of the picture E is also concave up. Oh, so the E is not inflection point. Okay, because it's concave up and concave up. The second derivative does not change sign. So E is not an inflection point. Okay, so E is not. So concave up, E is not inflection point. Okay, but D is an inflection point. D is. So I think I mean D, like the point D in the above picture. The second derivative does not exist at D, but D, you can see the second derivative change signs. So D is inflection point. So far, so good, everybody? So it requires the second derivative must change sign. Okay, let's continue. Example 1. Find the intervals of concavity and the inflection points of the following function. Okay, so here we need to find the second derivative. So you first find the first derivative. Okay, what's the first derivative? Let's see. Josh, what's the first derivative? And then? And then? 12. Right? That's the first derivative. And we need second derivative. Layla. Yes. Right, everybody? So the process is similar. We also need to factor. What is the common factor, Blaine? Yeah. After we factor out 12, what's left? Very good. Can we factor further? Well, what are the factors of 3x squared? Yeah, 1 and 3. So 3x and x, right? And factors of minus 1. Plus or minus 1. But where do you put the plus 1? Where do you put the minus 1? Yes. Yes. So multiply the outside, what do we get? Multiply the inside, we get, oh, when we add them, we get, yeah, so that exactly match the middle term. So this is the correct factoring. We set this equal to 0. Oh, okay, let's continue on Monday. Have a nice weekend. Please do your practice exam. Remember, use pencil first, and once you put the solution, use red pen to grade your work. Estimate your scores, and also write down the correction. Have a nice weekend.